Okay, in this video, we're going to talk about probability, specifically insurance. What is insurance? Why is it good for the person who's buying insurance, and why is it good for the company who's selling it? What is this value proposition of insurance? We're going to start, and you need to understand the basics of expected return to fully understand this lesson. I'm going to be depending upon your knowledge of this skill to build on so that you can understand the concept of insurance, which requires the understanding of expected return. I'll kind of do a simple bit of review during the lesson, but we're really going to be focusing on new material and require that you already understand those building blocks. So without any more said, we're going to go over to our insurance worksheet. Okay, so this is we're on our drawing pad now. We're going to be talking about insurance, but before we talk about insurance, we're simply going to ask you a question. So let's just say, and here's the situation, that you are a 16-year-old driver, and your parents have given you use of their $20,000 car for the year. What are you worried about? What are you worried about? Or maybe what are your parents worried about? So that's like question number one, and maybe question number two is the right one to be asking depending upon what type of household you live in. And the answer here is, first of all, the answers to these questions is one, your safety, because it's more likely that you're going to get into an accident than the average person, because 16-year-old drivers are new to the road, and they have less wisdom, less experience driving, and so they're more likely to get in a car wreck. But the second thing is, after the safety, which is the first concern, is the cost to replace the car if it is damaged. So what we're going to do is we're going to build a chart here, and we're going to look at, let's analyze. The first thing we're going to do, or the next thing we're going to do, is we're going to see what could happen. What could happen? And we're going to make this we're going to look at what could happen. What could happen? And we're going to keep it simple. And this is actually not a bad way to look at it. We're going to keep it simple, and we're going to say three things can happen. One thing is nothing. No wreck. And this cost you zero. Okay? Another thing that could happen actually is you could just get in a minor wreck. And let's say that cost you $2,500. Because it actually turns out that if you get in a minor wreck, you could damage a wheel, you could damage a fender, and these things can be kind of expensive. And remember, it's a $20,000 car that we're talking about in this case. The last thing that happens is a major wreck. And this would be what they call totaling the car. And this means it's a total wreck. The entire car is damaged. To fix it would cost more than $20,000. So we're going to say that would be $20,000. That would be $20,000 worth of damage. Now, realize that if you did $50,000 worth of damage to the car, which is actually possible, you could damage a car so badly it would cost more than $20,000 to fix. You would simply, in that case, just buy a new car for $20,000. So you can never really do more than $20,000 of damage to the car because it can always be fixed by being replaced. So we're going to use this simplified model to understand what insurance is. And we're going to do it by evaluating the case, the expected cost, the expected return for this case. So the expected cost, it's just like, remember flipping a coin, if we could lose $45 for a tail or make $50 for a head, you know, the expected return is not negative 45 or positive 50. The expected return is somewhere in between, a number that you'll never get, but is an average of those two cases. So we got to find the average kind of case. And the way that we find the average return, or the average return, which is in this case called the average cost, which is also called the expected return, is we build our chart. So this is we list our outcomes. We list our probability of each outcome. We list our cost or our return. And then we list our expected cost for that case. And then we evaluate our total number. So I'm just going to build our chart here. And we're going to start to fill in numbers. So our outcome 1 is no wreck. And remember, this is simplified. And then we get into a minor and a major wreck. Okay, our probability, and so we have to consider our possibilities. And we're just going to assume that we know the answer. Let's just say the chance that nothing happens is actually pretty good. It's 75%. A minor wreck we estimate at 20%, and a major wreck at 5%. And you know, 1 in 20 times you're going to total the car. For a 16-year-old might total the car. This isn't unrealistic. A minor wreck 20%. 1 time out of 5 you're going to get in a fender bender, and then 3/4 of the time, or 75%, nothing will happen. So most of the time nothing's going to happen. But boy, and something really bad could happen. So let's look at this and let's figure out what our expected cost is by doing our chart here. Now, in this case, and remember, we've always been doing this thing called our cost to play, or our cost to play. And this will come into play later on. But in this case, it's nothing. The cost to play is $0. Because we're not talking about insurance just yet. So let's just leave this line in here, because it's going to make a difference when I start to explain why we buy insurance. Again, this case is the case with no insurance. We're just looking at what we could expect our 16-year-old to cost us, or if we're the 16-year-old, what did we expect to cost ourselves if we get into a wreck. So what's the cost of no wreck? The cost is $0, because there's no wreck, no cost. Our expected cost is 75 times 0 is 0. So our cost, if we get into a minor wreck, is $2,500. And if we multiply this out, 20% of 2,500 is $500. You can use a calculator if you like. 5% of, and 20,000 is our cost in a major wreck case. And 5% of 20,000 is $1,000. So the way that we get our total expected cost is we just add these down: 0, 500, 15, 1,000, and our total is $1,500. Doesn't cost us anything to play, so our total is $1,500. Now I want to do one other thing, and we'll just write this over on the right. We're going to erase this, and we're going to ask ourselves, what is our best case, our average case, our worst case? Let's just see. So let's put that over here. We'll put that in like this brown color, orange color. Okay, so our best case scenario, our best case is $0, right? This is our best case. Our best case is that we get no wreck. It costs us nothing. Awesome. So now our worst case is the one that's the most expensive. So that's not no wreck. It's not a minor wreck. Our worst case is this major wreck. Our worst case is it costs us $20,000. And then our most likely case, we got to find the one. This is the most expensive, right? The worst case is the most expensive. Our most likely case is the one with the highest probability. And the one with the highest probability is no wreck again, so 0. That makes sense. It's most likely that nothing happens. Our best case is nothing happens, $0. But our worst case is $20,000, and that's expensive. The worst case, this case, this case is really bad. Really bad. What's really bad? Ooh. Really bad. Black looking evil cat. That is not our best case. Our best case is happy cat. Whoops. Let's move these guys. So our best case is happy cat. Our worst case is evil cat. All right. Oh man, no, that's not our worst case. This is our worst case. That's our worst case. Man, we don't want that guy showing up. Worst case. Okay, good. So what is this guy called? That's called Iron Golem. It's our Iron Golem. We got Happy Cat and Iron Golem. Okay, whatever. So now we have this best and worst case, and we're trying to evaluate what can we do to not have this worst case. We don't want this worst case. So let's look. We're going to keep these same possibilities up here of what could happen. But now I'm going to make you a deal. I'm going to make you a deal. And here's my deal. And this is the insurance deal. So let's call this, we'll call this light blue or whatever. And we'll say, okay, insurance, you pay me $1,700 this year. And if you get into a wreck, I will pay it. So I am the insurance company. So you pay me, the insurance company, the insurance company, $1,700 this year. And if you get into a wreck, I will pay for it. Now, realize, let's go back real quick. No, let's just keep going. We'll keep going along this front. So what I'm going to do over here is I'm going to, let's see, I'm going to go to my files. Let's see, I'm going to make, nope, not a new file. I'm going to open this file and I'm going to duplicate this file. Okay, so we can come back to this one. So now what I'm going to do is I'm going to redo this whole case, and we're going to look at a different return here. All right, so we're going to have the same probabilities, and we're going to look at the cost and the expected cost, and we're going to do another evaluation, and then we're going to come back here and make talk about the two cases. Okay, so now We'll put these in this light, yeah, same color. Okay, so now what's going to happen is we're making this new deal, and if you get in a wreck, it's not going to cost you anything, but you had to cost to play this game is $1,700. Cost you $1,700 to play. So if you get a no wreck, the cost to you is $0. And now if you get a minor wreck that happens 20% of the time, it costs $2,500, but you don't have to pay anything. Nothing. So 20% of nothing is nothing. The insurance company is going to pay it, so the customer, you, don't have to pay anything. Likewise, if you get into a wreck and you get in a major wreck, it costs $20,000, but you don't have to pay anything. So what is our expected cost? Our expected cost is $0, $0, $0, $1,700, because it cost you $1,700 to play this insurance game. Now let's look back at our best case, worst case, and most likely case. So let's see here. Our best case is $0, just like before. No, our best case now is $0, but we had to pay $1,700. So our best case is $1,700. Our worst case, a major wreck, we pay $0, but we had to pay the $1,700. So our worst case is $1,700. And our most likely case is 75% with a cost of $0, but also $1,700 to play is $1,700. So we can count on the fact that it doesn't matter. Whatever happens, we pay $1,700. But look back at the other case. Our other case, we could pay anywhere from, we could pay $0, but could pay $20,000. In fact, we might not even get in our car very much because we're scared to go out and drive it because we don't want to pay $20,000, which is a terrible thing to happen, which is why insurance exists. Now, let's just finish off real quick with one other thing. One last thing is, and we need to use our knowledge of expected return. So let's erase this concept of insurance from over here because that's on our other sheet. So let's see. Let's pretend now that we're talking about let's talk about 1,000. Let's use a darker color here. So now we're going to be talking about 1,000 drivers. 1,000 drivers. So if we have 1,000 drivers and the average one is going to cost us $1,500, is going to do $1,500 a year, how much damage do we expect 1,000 drivers to do? Well, we expect the one to average 1,500, so 1,000 drivers will do 1,000 times the expected return, the expected cost, and that equals 1,000 times 1,500 equals $1.5 million. $1,500,000. That's our average cost, or expected cost. And remember, if these percentages are right, we can assume that this is going to be true, really close to true, because of the law of large numbers. So the law of large numbers that we've learned about tells us that as we approach infinity, we start to do lots and lots and lots of these trials, that the total cost is going to approach the average cost times the number of times you do it. So this is going to cost $1,500. That's how much damage will be done. Now, we've already agreed, I think we've already agreed that we want to avoid this worst case and that buying insurance is a good thing. So let's remember this number, $1,500,000. And let's come back to our other case. So our other case here where we bought insurance and we're the insurance company. So now what would it cost? What does it cost What does it cost 1,000 drivers to insure? To buy, which means to buy insurance. So 1,000 drivers to buy insurance. One driver costs $1,700, but 1,000 drivers, it will cost $1.7 million. Or $1,700,000. Now, what is it going? So that's what it costs the drivers, and so this is how much money the insurance company makes is $1,700. Now, remember how much damage the insurance company is going to have to pay if these probabilities happen. They're going to have to pay out. Remember, $1.5 million. That's the number that we calculated. So if the insurance company takes in $1.7 million and they pay out $1.5 million, they profit $200,000. And that, for the insurance company, is a happy cat because they're going to make $200,000. So that's why it's good for the insurance company. The insurance company makes money. Insurance companies work for a profit, in this case, $200,000. And remember, in our other case, what is a good deal for the customer? The customer, here's his happy cat. The customer's happy cat is he avoids the worst case scenario. So let's write that in a big happy green. The customer, what the heck? Green. The customer avoids the worst case for smaller fee. Right? That's the customer's happy cat. The customer avoids the worst case. We'll never have to worry about paying $20,000. The customer simply has to budget $1,700 to buy the insurance. So that is the basis of insurance. Customers avoid the worst case by paying a fixed fee. Insurance companies make money because of the law of large numbers, says that they can make a little bit of money per customer if they insure against bad things happening. So hopefully this was a useful lesson. We'll come back to you here, and we will see you next time. I'm going to start next time. I'm going to talk about insurance. I'm going to start talking about deductibles and the importance of there's some other things that we need to learn about insurance that make it a little bit more interesting and a little bit more complicated, but are realities in this world that you'll need to know when you buy insurance one day, and so that you can make good decisions for yourself. Over and out. Oh, well, not over and out just yet. We want to make sure that we can just